Okay, so let's continue. First, before I continue with the code that I showed you, a question, does anyone of you have any questions or comments? I hope that everyone's Google Colab is now working, or you have a local installation instead. So let's return to the notebook LNTK introduction. And just to repeat what we did is, so we converted a list of all the words in all documents to lowercase. We tokenized this list, so converted it to a list of words, and we input this list of tokens, list of words, to nltk.text. And then what we could do is we can use the commands we already learned that can be applied to nltk text objects, such as asking for concordance of a certain word. We can also ask for concordance of a sequence of words. So to see the context in which the words high school appear in this document. For example, what we have to keep in mind if asking for concordance of a sequence of words, we have to supply these words as a list. So as a list of words. Square brackets mean a list, and the list consists of high and school. If we don't do that, if we just write high school, then we will not get results. So basically, we put a list here as a parameter to concordance function, and we see the result. High school athletes, new high school system, and so on. So that's important to keep in mind. Use a list. If you just write high space school, these are two separate words, so it will not find them in this list of words. Yes. Oh, this one.
Yes. And then, but I don't see that you would add any number of characters, but it seems like much less.
That is because I did not execute this step. I kind of skipped over it. But if we execute it, we see that the width of this concordance is larger.
Yes.
Mm-hmm.
And now, white has chosen to be not so white?
Well, it uses the parameters that you supply to it in this command. If I wanted more lines and more widths, I have to supply it as an argument every time. It does not remember that setting. I don't know, maybe someone has an answer to this. Well, I don't really have such a rule of thumb. Let me see. Well, width of 100 characters seems to be already sufficient and not too much, I would say. But really depends on your text. For social media text, it would be shorter, perhaps. For larger text, it can be this 100 characters or so. Does anyone else have comments on the width of concordance context that you would want to see? Ideally, it would be the more the better, within reasonable bounds.
Yeah, I just would like to comment that usually in some corpus analysis programs, the width is in the number of words, not in the number of characters.
Okay.
So that would be a different amount, right?
Here we can supply the width as a number of characters, so not words. So we just have to kind of pick the number of characters that would cover the number of words that you are interested in. But yes, this, at least as far as I know, there is no parameter for number of words. We can look for help, but as far as I remember, there's no such thing. Yes, it's just width, the context window width in number of characters. Maybe we want to save this concordance list to a variable. And maybe we want to write that concordance list to a file later on. In that case, we can use this method called concordance list. And this concordance list, unlike concordance, will not print this concordance, output, but it will save it to a variable. And if we save it to a variable, we can use it in later commands. For example, we can save it to a file. So we have a list of concordance lines, which is 46 items long. So apparently that's the number of matches that we have for high school. We can look at an output list line where we have high school in context, and we can also remind us what was the query word, that it was high school, or query words in plural. Now, since we have this output list, which is a list of concordance lines, we can write it to a file. So let's recall how we write things to a file. First, we need to open that file for writing. So we use this command with open. Then we supply the name of the document where we want to write to. And the important thing is we need to specify that mode is writing, so that we want to write something to a file and not read from it. So we open that file and store a pointer, a reference to the file in variable called f. And then within this with open block, we write a for cycle, for row in output list. So for a row in our list of concordance lines, let's write this row to a file, and let's remember to add an enter character or new line character after it. And once we have executed this part, the file is saved to our local file system, which in Google Colab case is here under files. So files, myconcordance.txt. And we can click download the file, and then we can do something with the file. So it's quite large because I think I specified 200 characters. And you can see that high school is here in the middle of these text sequences. So when you are using Google Colab, it's important to download these saved files because after some time Google Colab may delete these files. So when you write a file, then let's also download it. So any questions at this point? If you have some difficulties running the code or following it, then raise your hand and someone will help you. Okay. Now, we may also want to normalize text. We already looked at how to convert text to lowercase, how to clean the text, remove its stop words. Now we may want to go further and either do stemming, so stripping affixes from words, or we may want to convert words to their basic form of the word in dictionary to do lemmatization. And NLTK offers you both stemming and lemmatization functionality. But it's limited to some languages, so to English, Latvian is not one of them. But let's pick English text for now. So let's choose a fragment of a text here. That is raw text that we will work with. And we'll first split the text to tokens. And then we will use Porter stemmer to convert this text to its words in the text to their stems. So listen, strange, women lie in pond, distribute, and so on. Or we can do lemmatization to convert these words to their basic form in the dictionary. And for that, we need to download NLTK resource. If I recall correctly, it's multilingual WordNet. And then we can lemmatize this text. And the difference that you will see is, so we have listen, strange, woman, lying, in pond. So these are whole words from a dictionary. And this way we can convert different forms of the same word to this basic word. So we can then get better maybe word frequency distributions and so on. But what can we do if the language that we want to work with is not supported by NLTK? One of the options is, well, finding another tool to do this lemmatization. And one such tool is Simplemma. So that is another library that you may need to install, or maybe it's already installed on Google Colab. We'll see. So first, let's again use a web address. So our text corpus that we want to work with, Latvian old newspapers, can be found on the web at this address. And we will use pandas.readcsv command to read text from this web address and to separate it using the tabulation symbol. So again, we have this tab-separated values kind of table. Let's load the file and see what's in it. Here we have 4 columns: language, source, date, and text. Same as before, we can, so this DF, it's called pandas data frame, that contains this information that you can see in the table. Or in the table you see the first 5 rows from that table. And let's sort these values by date. Let's look at the beginning of the table again. we see some articles and their dates. And let's use this data frame to create an NLTK text object. So how do we do this? We create a list of documents, a list of text in these documents, by taking the text column of all the rows in this data frame, in this table. Then we use a new line character to join all these documents together. So in this case, we will have a variable that contains a large number of documents all joined together, every document on a separate line. Then we will lowercase all these documents so that we don't run into uppercase, lowercase issue, and store that in the variable file contents. And then we will tokenize this text using word tokenizer from NLTK, and we get a list of tokens which we store in the tokens variable. And finally, we create an NLTK.text object based on the tokens that we just created. So that is our text. It takes some time, but it completed its task. And let's see what happens if we just write text. It shows us the beginning of the text. And we can look inside this document and look for concordance of the word basketball. And we can see that there are 3 matches. But let's see that we want to normalize this text. And let's see how frequently the word basketballs appears in this text. Okay, we went through the text and checked for items basketballs. That maybe even was not necessary, because already in the concordance we saw that it appears 3 times in the document. But maybe there are other variations of the same word in the text. For that, we will use regular expressions, which can be a whole workshop on its own, but I will show you a simple way how to use them. So to use regular expressions, which lets us select some parts of the word, in this case, we first need to import regular expression library. And then let's write a for cycle that goes for item in text. So let's go through all the text, all the tokens in that text, which will be stored in the item variable. And let's do the following actions with every token in the text. And this action is regular expression.match. And then I write R for raw string, and I write just the beginning of the word, and then I tell regular expression library that I'm interested in words that start with basket, but then can have anything after basket. So that might answer your question about how to find what other forms starting with the word basket are in the text. And then when we find a match for some token that starts with words basket, then we print out the match. So what this regular expression does, it says find, or rather it says choose all the items that start with letters basket, and then it has any character any number of times. So word basket would match, and words that have basket as the start of the word. And let's see what we have. So we have basketball, but basketball in different forms. And also word for basketballistas, which is basketball sportists. Okay, so what can we do if we want to find, for example, concordance for this for basketball? Let's import a library called Simple. That's a library, okay, and we don't have it on Google Colab. That means that we will have to use this command pip install. I will remove the comment from this line, and I will run command !pip install Simple. You will also need to do that. So let's run it. Python downloads this Simple library. And after it has been downloaded, we can run import Simple. And let's import it as under the name SL. So, does it work for everyone, or are you finding some errors? You need to uncomment, remove the hash from this line, and you need to run these cells. Okay, so we have imported Simple, and now we can go through the text and lemmatize all the tokens, all the words in this text. So convert the text, the tokens to their basic form. So how do we do this? There is code consisting of a few lines. In this case, we will store the result in a list called buff and from buffer. This buffer will at first be an empty list. These square brackets means that please create an empty list, so without anything in it, and assign it to the variable called buff. And the list is empty at first, but we will use the command buff.append to add things to this buffer. And then what we do is we use a for cycle to go through every token or every word in this text. So for every token in the text, we'll assign this token to the item variable. And then we will call SL lemmatize item language equals Latvian. So we'll ask Python, we'll ask this Simple library to lemmatize the word, and then we will assign the result of this lemmatization, we will append that to the buffer. So in the end, we will have lemmatized all the words in this text. Maybe I will show you at first how this Simple lemmatize works on its own. So I hope that it does actually work. So I will write basketball in one form with U at the end, and you can see that this lemmatizer converted it to the singular form basketballs. So the lemmatization works, and let's now run this command, and let's look at first 20 tokens. And we have small, money, health, care, idea, and so on. So these words have been converted to their basic form. Now we can create NLTK text object from them, and we can run concordance now, and you see that if before we had only 3 matches for word basketball, now we have 15 matches. So we found more places where basketball has been mentioned. But the downside of it is that we have changed the text. So these are not anymore easy to read sentences, let's say. So that's a downside. Now, that was what I wanted to show you about NLTK. We don't currently have time for exercises right after this notebook, but that will be your task for the third part of today's workshop. So that's when you will be able to work with texts, including exploring them in NLTK. So are there any questions or comments? Yes?
If the text doesn't have the structure of a table, or it isn't separated by commas, is it possible to still use it? And like, what's there about
If the text is not a table in table format, can we still use the text, right? Yes, we can do that. So let's see. I will upload, for example, Alice in Wonderland to Google Colab. And now let's see how we can access that text. So its name is alice_wonderland.txt. So Alice, was it that? Let me check. alice_wonderland.txt. So first, let's create a variable that contains the name of the file. Then let's create a new cell, and let's try to read contents of this file. So for that, we need to open the file with open file name, comma encoding equals UTF-8 as file, text equals file.read. So this command here will open the file with the given file name in the current directory, which for Google Colab is this directory here. It will specify the encoding. That's a useful thing to do. And it will remember the pointer to this file in variable f. And then we can use the command f.read to read all the lines from that document. So that will be stored in variable text. And we can look at the beginning of this text, which is the header from the Project Gutenberg collection. And later on, there's the actual text of Alice's Adventures in Wonderland. Now we can tokenize this text. Let me see how we did it before. And we can convert it to nltk.text then. So I copied a fragment of the code. I will put it here. So we read the whole text of Alice in Wonderland. Then we tokenize this text and store the result in the tokens variable. And then we create NLTK text object from these tokens. So that took some time, but not too much time. And then let's use the same concordance, and let's look for word Alice. And there we have this text. Okay. Actually, interesting. In the case of concordance, it appears that Alice in capital letters is matched as well. So it could be that a concordance program is case insensitive. Let me see. If I look for Alice with lowercase a, it also finds Alice. So the concordance program part is case insensitive. All right, so that was the text, the code fragment for opening your own file in NLTK. Any more questions? And you will get to practice that in the third part of the workshop, after the break. So let me see. We have finished introduction to NLTK, and now let's choose the next notebook. So there are notebooks which we can't cover today, but I have prepared them anyway. You can look at them on your own, which is NLTK bonus, which looks also at collocations, bigrams, trigrams, I think, and a notebook on pandas, which goes deeper into how you can work with tabular data in using pandas. And how to use that for natural language processing. But here, let's continue with the notebook called Day 2 Visualization. So please go to GitHub, download this file, and upload it to Google Colab. So I will also open Colab, like new Colab, and I will find a notebook called Day 2 Visualization, and I'll upload it to Google Colab. And this notebook will demonstrate how to do visualizations using a number of libraries. So Matplotlib and Seaborn library, Plotly library for interactive visualizations, and finally word cloud visualization. So let's connect to the Google Cloud. I hope that it will be fine. Yes, it appears that we have connected. And let's get started. I will give you a moment to open the correct notebook. So it's Day 2 Visualization. Yes, and if you need assistance, then raise your hand. Sergey, there's in the front there was a question. Anyone else needs help? Okay, so there were some technical questions to solve. But now, hopefully, everyone or most of you have the Day 2 Visualization notebook open and ready for work. You can always check by typing a simple command like print hello to see if Colab works. So if it obeys your commands. So I hope that all the libraries are installed in Google Colab, but if not, it will let us know. So I'll execute this cell here, and we'll import pandas, matplotlib, seaborn, and NLTK. And we will use, again, a corpus of documents that is available on the web. And we will use the command read CSV to read this comma, or in this case, tab-separated document. But as you saw already in at the end of previous notebook, you don't need to necessarily have a table with documents. It can also be just a text file that we can read, for example, from the current directory on Google Colab. But in this case, let's use this Old English newspapers dataset. We have read the table. Let's look at the first few lines or rows of that table, and we are interested in the column called text. And now what we can do is here I am taking all the values of the text column, and I'm joining them together using the new line character as a separator. So that will give me a very large string value that consists of all the text separated by new line characters. And then I use the split command as one way how we can tokenize the document, just splitting it by white space. So in this case, I use Python's built-in command that takes a text string and splits it whenever it sees space, new line character, or something similar. Maybe I will split this command into two, just to show you step by step what I'm doing here. So all text now should be a list of tokens, a list of words in this document. I will show maybe a shorter list of 30. So there is the text, which was split into tokens. Those are words, but sometimes they have dots or commas after them. We may want to use a different tokenizer to get rid of these commas and spaces. But here I just used Python's command .split. It was easier that way. And now let's create NLTK frequency distribution object based on this text, and let's take the most common 20 words. So this is where we find out word frequency in this text, and we took 20 words. So oh, that's not right. Ah, yes, I see what's happening. I am printing all text content again, but we don't need to do that because we already printed it here. So we create frequency distribution and take 20 most common words, and that's values we get the, to, and okay, these are mostly stop words, but let's work with that for a moment.
I have a question.
Yes.
Does it matter in this case, like you said, that the splitting doesn't And I was thinking, does this mean then that it also excludes the, I don't know, the punctuated words?
Well, it doesn't exclude punctuated words. They are still there, but they are together with punctuation.
But in the word count, like when it calculates the frequency.
Yes, you are correct that those would be considered separate different words. So to improve this, we would need to use a different tokenizer, not just splitting them. Okay, so a tokenizer that I used before. But for now, let's work with this, let's convert all this frequency distribution. So the value in the variable all underscore fdist. First, let's convert it to a Python dictionary, and then convert it to pandas series. So this pandas series will contain both the word and the frequency of this word. So here is the contents of this pandas series, where we see that every row has a word like that, and the number of occurrences of this word. And now we can plot this word frequency using matplotlib library. So we imported a part of matplotlib library under the name plt from plot. And we are interested in getting a bar plot of this frequency distribution. So we supply indexes, so the words as one coordinate, we supply it the list of words and the list of corresponding values. And we will also ask the labels on the x-axis to be rotated slightly so that they are more legible. And this is the plot that we get. So we see that the word "the" appears most frequently, and then there are other words that also appear quite frequently in the text. So that's our first plot that we do. Now, let me see what else we could do. We can make the plot a bit nicer by adding labels or adding titles to x and y axis and adding title for the visualization itself. It will be like this. So we could also use other kinds of plots in matplotlib. For example, if we give it a command .plot, it will use a line plot. So here is a line plot with the same values. I would argue that the bar chart was more informative, but here we have this text frequency as a line chart as well. Does the visualization work for everyone? It does. Okay, good. That's great. Here I also have a demo of a scatter plot, but right away I did not have an example from natural language processing to show. So instead I will show it using synthetic data about countries. So imagine that we have countries. We have information about country population and country area. And then we can build a scatter plot using area as x-axis and population as y-axis. So how do we do that? First, we prepare the data. So we have data in 3 variables: countries, population, and area. Then we create the plot itself by using commands plot.figure to prepare the space for the plot, and plot.scatter to create the scatter plot. And we supply the area and the population as values for x and y axis. And then we will also want to annotate these points with country names. If we don't do that, we might not know what country these dots belong to. So see, here we have a scatter plot. X-axis is area, y-axis is population, but we don't know what each dot means. So that's why I had here code, which I removed briefly, where we go through countries. So 4 cycles through countries, for country in countries, and we use command plot annotate, and we annotate this plot with the name of the country. So we use the location from area and population variables to find out where this text should be located, and then we add text to this visualization. So now we see that we have a scatter plot here, and we have added labels to these points: country A, country B, C, D, E, and so on. So that's kind of a brief overview of plots in matplotlib. And I hope you can follow along and also create visualizations, perhaps based on your own data. I will wait just for a bit so everyone can get up to speed. Shall I show this again?
Could you tell what is the x, y text? Like there are coordinates or?
This?
Yeah.
Okay. So XY text means the offset of the text. So the text is tied to a location on the on this chart, but if we did not have XY text, then I believe that this label would be almost on top of that dot, and XY text moves it five spaces to the right and 5 spaces up. If I recall correctly, I will try to remove it, and that's the result. So you can see that this XY offset makes the table a bit, the visualization a bit nicer. And there was another question. Who had it? Okay. Okay. Now let's look at stop word removal again. For languages like English, we can use stop words that are included in NLTK. So at first we download the list of stop words, and then we create a stop words variable which points to stop words for English. So these would be the words that we will, we want to remove from our text. As the next step, let's convert this list of stop words to a set that is a different Python data structure, and a set makes these word lookup operations very fast, so that we can very quickly determine if a word is in the list of stop words or if it is not. So let's execute this part, and then let's remove stop words by using list comprehension again. So in list comprehension, we go through all the words in the variable all text, which has 171,000 words. And we will return word, but only those words for whom the condition if word.lower is not in stop word set is true. So basically, we will collect all the words that are not stop words. And we will store that in a new variable called all text stopped. While we are at it, let's remove some special characters, like a dash or two dashes. So we create a variable special characters, and we do another list comprehension where we go through all words in the variable all text stopped and filter out those words that are in the list of special characters. So now we assign the result to all text stopped, and all text stopped will contain only the words that are not stop words and that are not these special characters. And then let's print the first 6 words or so, and that's what we have: home, alone, apparently, St. Louis, plant, and so on. Yes?
Can we edit the stop words list? I mean, maybe I want to look at how frequent I, me, my, myself appears, but I don't want to look at how frequent we, ours, ourselves appear. Can we edit this stop word list?
Can we edit the stop words list? That's a good question, thank you. Let me think. So you would want to remove some words from the stop words list so that they are included in this chart. Okay, a good question indeed. Let's look at the type of the stop words list. And it is just a list. If it is just a list, what you can do, well, one thing that you can do is just remove these words one by one. So if it's a list, then you should be able to use a command remove, stop words remove, and let's say we want to remove word I. Then we would say stop words equals stop words dot remove I, and that should work. Okay. Stop words. Just a moment. Okay, so that is a bit tedious task, but you can use the command remove, and with the command remove, you can see that I removed this first occurrence of I. So you could use a number of stop words remove commands.
Can we have a list of the words we want to remove from the stop words, and then just remove that list?
We could do that as well, yes, that's a good point. So let's see how we could do that. Let's call that a keep list equals I, my, our. And then we can go for word in keep underscore list. And let's add a check if word in stop words, word remove, like that. And let me rerun this command here to retrieve the list of stop words. And let us run this code here. And you can see that me, myself, we is still in the list, but I, my, and our is not in the list. So that's indeed a better way to write this. Just have a list of words you want to remove from stop words, and just do that.
We can import that list from someplace else.
Yes.
Maybe the list is a lot longer, or we can just plug it in from there.
Yeah. Yes. But this stop words list from NLTK corpus is nothing special. You could also create your own stop words list, where you use regular text editor to remove the words that you want to keep. Okay, so we removed some of the words. We create stop words set, and here we have now all text with stop words removed. And now, since we have all text stopped, with all the text with stop words removed, we can draw frequency distribution again, but this time it will be a cleaned up text, like I said, with stop words removed from the text. So we will create frequency distribution of the text contained in variable all text stopped, and we will look at 20 most common words. And while we are at it, we will convert this result, all fthis stopped, to pandas series, so to something that has a label and a value. And let's go through all fthis stopped and print the result. So here we see that word said appears very many times. I appears as well many times, and we can see that our tokenization was not that great, that we had punctuation added to the words. If we remove this punctuation, then said would be in even higher. And now let's draw a bar chart of this result. Just let me check. Okay, we have to finish already for the break. That was quick. Okay, let's display a vertical bar chart. Oh, that was yesterday, sorry. 30 minutes more. Okay, good. I panicked for a bit. Thank you. Yay! Great, we can go slower again. Okay, so in any case, we have the text with stop words removed, and we have found the frequency distribution of words in that text. And now, since we have some time, are there any questions or comments?
What do we do with said and said with
Oh, said and said with a dot. Mm,
So it's treated as different words in the list as well, not only which are there.
so what do we do with these words with punctuation?
Yeah, do we just, I don't know, add them up separately or something else can be done?
Well, that was poor processing on our part. What we should have done is we should use a better tokenizer so that this dot or comma is split as a separate token, and then it can be ignored. So that's earlier in the process where I read the file over here. I used split, but maybe I should have used a better tokenizer there. Yes, that was quite a while back. Let me think. So let me show the other visualization. So we also can visualize it as a horizontal bar chart, and we can also visualize it, for example, in the reverse, so that we see the most frequent words at the top. Now, so your question was about this punctuation, right?
Yeah, but I want to see the total frequency of said and not said separated.
Regardless of punctuation. Okay, I will get to that. And there was one more question. Who had?
Actually, it was the same question. I wondered if it wouldn't make sense to remove punctuations, exclamation marks, and so on.
Yes, it would. It would make sense to remove them.
There's a very interesting question in the chat about reading emojis.
About emojis? Can it read the emojis? It should be able to read emojis too, if we are using UTF-8 encoding. Well, you have to check it for yourself. So do an experiment, see if it works or not. But it should, I don't see why it would not work on emojis. Unless you filter them out. Because if you filter out and leave only words that have alphanumeric or alphabetic characters, then of course emojis will be filtered out. But if you don't filter out these characters, then an emoji should be there as well. Yes?
What about some emoticons?
Sorry?
You know what an emoticon is?
Emoticon?
Yeah.
But that's same as emoji, no?
Not necessarily. Emojis are sort of like more like images, whereas emoticons are like different symbols written in a sequence that resembles a face.
Ah, so colon, dash, well, maybe you can find a text that has these emoticons and we can see for ourselves. But basically, it would depend on the tokenizers that you use. A tokenizer might just ignore these characters, it might split them into separate tokens, or it may leave them as they are. If they are left as they are, then I don't see why they shouldn't appear. So it depends on how you split your text into tokens. But yes, and that's someone for the audience, perhaps both for emojis and for emoticons. See how it works. Let us know. That would be an interesting task indeed. Okay, now, yes.
Just to add, because we remove, on the step of removing stop words, we also remove special symbols. Can't we add just a period there or exclamation point?
No, that would not work because I think we were removing the whole symbol, the whole.
Because they're tokens, because they're right next to words, and that's the tokenizer's job.
Well, I have another question. What about hyphenated words?
A good question as well. Hyphenated words. It again depends on what your tokenizer does. If it considers hyphen as a part of the word or as a separator. If it considers a hyphen as a separator, then you will end up with two different tokens. If it considers it part of the token, then it should be together, these hyphenated words. Okay. And
The way we do it now, it keeps hyphens.
it keeps hyphens. Okay, you checked. Thank you.
There's an exercise later with longer words, and it uses hyphenated words.
Indeed. Okay. So let's see. Well, I remember your question about the different tokenization, but perhaps let's look at that at the beginning of the next part. And do remind me if I forget it. I don't want to forget it, but yeah. Yes. Yes, but indeed these special characters, they should be get rid of at the tokenization step, I guess. That would be an appropriate place where to remove them. We could, of course, do something a bit hackish and just remove these special characters at the stage when we get text, but that's probably too hackish. We could use Python's command replace to replace all dots with all dots with empty space. And then we could say all text split, and then we could look in all text 100, and it doesn't work. Okay. Why did it work before then? I know what's... So, in this case, what I do is, well, first I join together these texts that we have on separate lines of the table, and then when I have gotten the full text, but before I split it into tokens, I replace all the dots with empty strings. So I kind of remove dots from that text. And we could remove commas as well. It already knows what we want to do. Nice. So that way we could get rid of dots and commas and so on. But a tokenizer might take care of this, and then you would not need to do this hackish approach here. Okay, what about stop words for languages not included in NLTK? Well, a stop word is just a stop words list is just a list of words. So we can get another stop words list, or we can create our own. Let's use the library called requests to get a stop words list for Latvian from a GitHub repository. It's not an ideal stop words list. It should probably be longer than that. but it's something that we can work with. So there's a project called Extra Stop Words, which has stop words for Latvian, and I think it also has stop words for other languages. So you can see that there are stop words for many different languages. But see for yourself if those stop words are good enough or not. But here we will use these stop words. So let's use the library called requests to get contents of this web address. So we get results of a web request. We take out the text of the request and split it by white space or new lines. We print a slice of 10 stop words, and we form a set of stop words just because the lookup will be faster. So here is the beginning of our stop words list. Now we can read our corpus like we did before. We will, and this time we are using Latvian newspapers corpus. And then after reading the corpus, we do the same dance again by extracting the text column, joining all these rows together, and then splitting the text on white space. So that gives us the contents of values for all text Latvian, for the variable all text LV, and we ask for frequency distribution of words, getting 20 most common words. Now let's see what happens if we try to print the frequency distribution. And we can see that our stop words list is really not good enough. So if we look at Latvian list, then okay, I see now. So what we did, we read the stop words list, we read our text corpus, we looked for 20 most common words, but there are many stop words in the list of 20 most common words. So at this point we have not removed stop words yet. That's why they appear here. Now let's first convert this Latvian text to pandas series. So all frequency distribution Latvian. And then let's remove stop words like we did before. So we go for every word in all text Latvian, but we keep only those words which are not in the stop word set for Latvian characters. And we also remove these special characters, which for some reason are all dashes. And this is our all text stopped, so text with stop words removed. And we can see now the frequency distribution, and we can plot it using a bar chart, horizontal bar chart. Now we have more interesting words like Latvia's, country or state, work, year, more, and so on. But we can also see that words kas or now, which should really be a part of stop words, that they are not. So we might need a better stop words list. But this was just a list of words, and you can create your own list. or better find an existing list. Now, what else is there to show? Maybe I will skip the histograms and seaborn part for now, so let's move a bit further. And one thing, we can return back to those visualizations, but I wanted to show you also the word cloud visualization, which can be quite nice at times. So to do a word cloud visualization, you need to find the section in the notebook that says just word cloud visualization. And let's import the libraries that we need to work with. So we import matplotlib as plot name, and we import word cloud. And yay, Google Colab already has word clouds. That's nice. So what we will do is, again, let's use the English newspapers corpus, read it using pandas. So pandas read CSV. Like before, we will extract the text column and split it into tokens using Python's split command. And we will remove stop words just like we did before. So here I'm just repeating what we already looked at before. We can check what this text looks like with stop words removed. So home, alone, apparently. It has these punctuation marks, so that's still a problem that we have. And now it should be quite simple to generate a word cloud. For that, we will join the words together again, just because word cloud expects to have not a list of words, but rather text. So our text will consist of all the tokens joined using spaces. So that's our text. And then we use we create the word cloud object and give it a command, generate word cloud based on the given text. And then we tell matplotlib that we would want to show the word cloud image on the screen. And that's what we get. So said, 1, 2, time, many, going, new, state, year, and so on. We might want to remove some more words to make this be more interesting. Million is there, and some other things. And then, well, you can find documentation for the word cloud library here on GitHub. So it tells us about installation and examples of usage of it. I don't look at it in the notebook, but you can also use these masks to create specific contours of word clouds. So this looks like Alice in Wonderland or something similar. Nice. You can change colors. So the library is quite powerful. I just showed you that this library exists and that we can do something with it. And let's maybe lower the maximum font size, and let's put this word cloud on a white background. So let me see how we do that. So we create a word cloud with these parameters here. For example, background color parameter tells that we want a white background color and that we want as a maximum 40 words. It also tells us what's the width and height of the word cloud, and then we create a new word cloud like this. And finally, we can use wordcloud.toFile command to save this word cloud to a PNG file, so graphical bitmap file, and you can then do something with this word cloud. Okay. How do you make a bar chart into a file? That's a good question.
You can just replicate the image and save as.
So I don't recall right now, but you should be able to save as image, right?
Yeah, you replicate it. Because it wasn't a, well, not, maybe not the bar chart, it's the word cloud. It's written there.
Well, word cloud we already saved to.
Oh, bar chart works as well. Oh, you replicate anything, click save image as.
Ah, you mean just taking the image and save image as, right?
Yeah,
Okay. Well, I opened it in a separate window.
well, it's a very, I guess, rudimentary.
Yes. Thank you. That's one way how you can do it. You can just save this image as, yes, indeed. But matplotlib should let you save this bar chart as well. I just don't recall how to do that right now. So ChatGPT it is. How do I save matplotlib visualization to a file? Okay, apparently there is a save fig command which should do just that. Oh, okay. So we can try to do that. The figure doesn't have high resolution, but there it is, right? Sample plot.png. So what else is left here to look at? There's more in the notebook, but you did very well, so follow the materials that we had. What remains is we can also draw histograms. For example, we can create a histogram of word lengths to see the distribution of lengths of words in our corpus. And we draw a histogram using a command plot.hist. And then we give it a sequence of word lengths and tell that we want to separate this histogram into 20 bins. And ouch. Okay, that array will ignore that. This is the distribution of lengths of words in our text. And we can see that some of the words, while most of the words are 4, 5 letters long, there are probably some words that cover this area here, so that have more than 15 letters. And then we can look for all the words that are longer than 15 letters and found the long words in our data set. So that's a histogram. Then I will ignore Seaborn part for now. Seaborn is very similar to, it kind of builds on top of matplotlib. You can also visualize bigrams. And maybe let's do that. So we can import from NLTK, we can import functionality to create diagrams of the document. Automatic saving failed. Something is not. Okay, for some reason this doesn't work. Maybe it's time for a break if it, and now it worked, of course. Let me quickly show you this part as well. So we generate diagrams, Home Alone, Lewis plant, and so on. We get the 20 most frequent diagrams. I think New York last year, New Jersey, ... We build a dictionary containing bigram as the key and frequency as the value. We convert it to pandas series, and then we plot the figure, horizontal bar chart, with our bigrams. So frequency distribution of bigrams starting with, I think, New York last year, New Jersey, St. Louis, and so on. And now it's time for a break. Okay, let's continue. People are still coming back, but so hopefully most will be here. Now, the third part of the workshop is for you to work by yourself, but maybe I'll tell about that a bit later when there will be more people present. For now, I will show you some parts of the visualization notebook that we did not look at yet. One of the parts that I did not manage to show before the break was Plotly graphic library, which creates visualizations just like Matplotlib does, but Matplotlib lets you create bitmap visualizations so images, while Plotly lets you create interactive visualizations where you can also scroll a mouse over some bar, for example, and see related values, related information to it. So they are interactive. And please find the heading called Plotly. Oh, sorry. Okay. At least, yes, you did not miss much. Please find the heading called Plotly. And under heading Plotly, we can start running commands. So first, let's import Plotly Express as px. So import the Plotly library. And then we can start preparing the data and drawing Plotly visualizations. So to prepare the data, we do the same as before. So you have already seen this part. We read data from TSV file, old newspapers in English. We split that text using the split command, Python split command. We find out the frequency distribution of this text, and again we'll take most common 40 words in the text. So far it's similar, very similar to what you have done before. One difference is when we have this frequency distribution stored in variable all fdist, we create a data frame. So we create pandas data frame with column names word and frequency. And we will use that data frame in subsequent visualization. So this is what this data frame looks like, the first few rows. So we can see that word "ze" appeared about 8,000 times, word "to" 4.4 thousand times, and so on. So we have word frequency information. Now let's create Plotly Express visualization. To create a bar chart, we just write px.bar, give it a pointer, a name of the variable containing our data, and indicates that words should be on x-axis and frequency should be on the y-axis. And when we execute this cell, a visualization should appear like this. And sorry, and how it's different from the other visualization is that you can hover on top of any of the bars, and you can see what word it's for and what exactly is its word frequency. You can also zoom in, if necessary, to see a close-up of your data. So it's similar to what Matplotlib can do, but it's interactive. You can interact with this visualization. Let's use a synthetic scatter plot example from before. So countries, population, and area. And we can display scatter plot using Plotly as well. So we can see for each country what its area and population is, and if needed, we can zoom in to certain part of the visualization. For a simple visualization like this, it's not really necessary, but if you have more complex visualizations with lots of data, you can use this property of Plotly. And one more thing that you can explore for yourself now is, if you go a bit higher up in the data visualization notebook, I just yesterday added a section about network visualization using Network X. So here I create a frequency distribution of bigrams and then create a visualization of a network formed by these bigrams. Well, actually, I said that you can explore it for yourself, but let me just quickly run them so that we see them all together. It shouldn't take too much time. So the key here is that we take bigrams of the text. We build a graph. This will be variable g. And let's see our bigram frequency list. So popular bigrams are, I think, New York, last year, New Jersey, and so on. You should also be able to execute these cells and see the visualization. So here we build a graph by adding edges to it. And then the next command builds a graph visualization using a layout called Kamada which is one of the layout options in Network X, and that is the visualization. It's maybe not very, it might not be very easy to overview this visualization, but that's the first step. You have a graph of words that are related to one another. We can try another visualization, another layout called Spring Layout, and that is a bit better already. So I said, we said, I think, I know, I want, I could. So different combinations of words. And one final thing that you may want to do with such a graph is you can save it in a standard format called GraphML. So you can save it to your disk. And then you can read it in another software. For example, software called Gephi. Let me see, GraphML. Okay, maybe Gephi, that's something to explore on your own. But basically, you can save a graph and then make even better visualizations in specialized tools that are meant for working with graphs. Okay, so that's it about the visualizations. So we have completed the visualization notebook. And the next notebook to open, it's a notebook that mostly has just instructions, so you can start by opening it on GitHub. It's the assignment for this workshop. So the assignment for this workshop is what you will do in the next, until the end of this workshop. No more me telling things, showing them on the screen, but rather you working with some text that you have chosen. We all, me and assistants, are here to help you. So do ask questions if you need some assistance. But the assignment consists of, you could say, 3 parts. Choose a text corpus to work with. You can take text from Project Gutenberg, or you can take texts that you want to work with. Analyze the corpus using NLTK or other tools learned in this workshop. And visualize the corpus using the libraries that I have shown you. So that's the assignment. Use Python commands or Jupyter text cells like these to explain what you are doing and why. And to get grades 7 to 8, you must do the minimum of these things. Prepare the text corpus. So, for example, remove stop words or do other things that you need to make the corpus useful. Analyze corpus word frequency and show at least one visualization of this corpus. It could be a word cloud if you wish. To get a higher grade, you need to perform additional analysis and visualization of the text corpus. So look at it from different perspectives, I could say, or visualize it in different ways. And include detailed comments of what you did and why. So to get a higher grade, you must do more than the required things for grade 7 to 8. Now, we mentioned ChatGPT in this course. So in other workshops, it could be that ChatGPT would be forbidden to use. But here, since we looked at ChatGPT, you are allowed to use ChatGPT and similar tools to help you with some questions, to get explanation of Python code, and so on. But the final work that you submit should be your creation. That means that you have to be able to explain what it does. You can use fragments, code fragments that ChatGPT gives you, but the work as a whole should be yours. You can't just take a whole program from ChatGPT, copy it in your work, and say that that's your work. You need to understand the code. You need to build this program. And in the submitted work, you should declare if you use ChatGPT, and if you did use ChatGPT, include information on what questions you asked and what were the responses you received. And so you can work on this assignment in this Jupyter, in this Google Colab notebook. And remember that to submit this notebook, you need to download it from Google Colab using File menu. So File, Download IPython notebook. And then there is a Google Forms link where you should submit it. So this is a link where you should submit this file under the heading Python Beginners Workshop 1A. Now this, you need to submit your work in case if you need these ECTS credit points. If you don't need the credit points, then it's up to you to submit this work or not. We would be glad to look at your work, but then in that case you are more free to do whatever you want with in this last part of the workshop.
Is there a limit to the size of the corpus we use, like a lower limit or an upper limit, or how big should it be?
The size of what?
The size of the corpus that we analyze.
Oh, there's no real limit, whatever you're comfortable with.
So like, if we can have something like 1,000, 2,000, 10,000 words, or does it have to be a lot more?
No, 1,000, 2,000, 10,000 words sounds okay. It should not be longer than just a fragment of text that I showed in these example snippets. So it should be some real text, but there's no real requirement on the size. 1,000, 2,000 words would be fine. Okay, there's a question if we can use PDF files to analyze the text in that PDF file. Okay, I don't know off the top of my head the answer, so I'll ask ChatGPT again. So, how do you load a PDF file into NLTK? So here I just asked for help to ChatGPT because I don't know the answer myself. There certainly, well, it depends on the nature of PDF file. If the PDF file is just images, this will not help you. But if the PDF file has text layer, then there are libraries and tools, including libraries in Python, that should be able to extract text from this PDF. So you need to install these libraries, and then it should be quite straightforward to get text out of it. So basically, I guess we should try it on some PDF files. So if you have a PDF file, maybe you can try writing this code and show me if it works or not for you. But here the suggestion is to use PyPDF2 library, and then you can write a short function like this to extract text from it. So that would be my first approach. If this won't work, I would search Google for help, I guess. So try it and let me know how it goes. Okay, so for this task, the next tasks that you are working on, you already did that probably, but if not, what you need to do is you need to upload this day 2 part 3 notebook to Google Colab, and then you can work in this notebook. So that's just the notebook with instructions. You probably are already working on it, but basically take this notebook with instructions about assignment, about grading, about submission, and so on. Then you can write some code here. You can execute it. Basically, you can write your program in this notebook, and when you are finished with it, then remember to download it. So file, download IPython notebook. That's what you need to do to be able to then submit it using Google Forms. Else who needs help or who has some questions? Okay, there and there. Fine. Okay, so thank you for participation. The official part of the workshop is finished, but if you need to finish up, then do that. So you don't have to leave the room immediately. If you need some more time, that's an option. And also, I realized that maybe this time was not enough to complete as much as you wanted to complete. For those of you who are submitting this task assignment for credit points, for example, you might need, or anyone else, in case if you need some help, we are still available after this class as well. So you can write me an email if you need any assistance. So I will write my email here at gmail.com. So you can write me email if you need some help. And again, we're not throwing anyone out at this point. So if you need to finish up, do so. Are there any questions? And thanks everyone for participation. Since the official part is over, thank you.